Welcome back, chat. Thanks for checking out the newest video. I don't have anything else to say. All right, here we are. Bet. What do? I'm stuck already. What's the derivative of x cubed with respect to x? 3x squared. And I'm just going to switch to this. Can you guys see this color? 3x squared plus, here's the hardest part of the whole problem. What's the derivative of y cubed with respect to x? Okay, y prime or dy dx? I prefer y prime also. Equals, what is the derivative of 64? 0, piece of cake. Okay, can we solve this thing for y prime? I'm going to do it in like one step, maybe two to simplify. Y prime, I would first subtract the x squared, or 3x squared. And then I'm going to divide by what? 3y squared. They're gone, and I'm done. Bless you. Cool. Now, we have a lovely implicit derivative. Nothing crazy going on with it. Feels hopefully okay. Questions before we kick forward into today's stuff? All right. Sweet. Okay. How's the homework? I already heard somebody, JJ, can you remind me what number you said was blech? On number 21, in case anybody struggled with it, we have the lovely function f of x equals 1/2. F of x equals 1/2 the natural log of this mass. 1 plus x over 1 minus x. Okay, fantastic. Should we immediately begin by differentiating? I wouldn't. You could. It'd be the natural log, so log rule with a quotient involved. Blah. Or if I see division happening in my argument, it looks like this is just an obnoxiously large subtraction. That's all this sign is. It's called a vinculum. Let's rewrite f of x. F of x instead can be 1/2 times the natural log of what first? Minus the natural log of 1 minus x. Now, this is not required, but if you didn't do this, blah, like your problem is going to be gross, it's going to be harder to simplify. Now can I differentiate it? And not only can I, but it's like a million times easier because there's no more quotient, no more anything bad about it. We can just like do it to it. So here we go. I'll take the derivative of the left, f prime of x, and the derivative of this side. Is there a constant multiple involved? So where does it go? What happens with constant multiples? Where do they move? To the front. Okay, so a 1/2 hangs out here. Times, now I'm going to use brackets just to keep stuff nicer looking. Stylistic choice, is it? How do you take the derivative of ln u? U prime, so there's 1 over u, which is 1 plus x. Minus, what's the derivative of 1 minus x? -1. So choice, do you want to write a -1 here, or can I just change this to a plus? I'm okay with just changing it to a plus over 1 minus x. Now, if you got here, you have the derivative. It is very different than what it looks like in the book. Should we flex our algebra muscles and just clean this up a little? More specifically, would you benefit from doing a little bit of algebra practice and simplifying? Okay, so when I look at this, I know what my first thought is, but what's your first thought for simplifying, Fern? Anybody else want to distribute first? You could. I wouldn't. Now, you might, and you'll be fine, just so you know. But if I think about distributing, all it does is make it harder to find like a common denominator here. Could we instead clean up what's in here first? Now, this is going to look ugly as I'm doing it, but I need a common denominator. This already has a 1 plus x, and this one already has a 1 minus x. I don't really care if it's a least common, as long as it's common, right? Because if it's not the least, something will fall out. What's a clever choice of 1 to multiply this one by? Whoa. 1 minus x over 1 minus x. And what's a clever choice to multiply this one by? 1 plus x over 1 plus x. And this winds up being awesome because what I see happening is a difference of squares. and stuff is going to fall out. It's going to be really easy to expand this. So let's just see where it takes us. 1/2, and then we get, in this numerator, it's a 1 minus x, plus, what's this numerator going to become? 1 plus x. And then down here, we have to make a decision. Do you want me to multiply it or just keep it factored? Good call. 100% of the time, we should just keep it factored. 1 plus x times 1 minus x. Unless it's a multiple choice problem in which none of them are factored out. But there's very few situations where I would say actually expand this out. Anything left that we can do? Yeah, Mr. Holloway, it's obvious. We do this. You could distribute. There's something even more obvious in distributing. Oh, my x plus x and minus x, they're gone. Now, when we clean this up, when we write a single expression, this is where I would stop. I get 1 times 2, or 1/2 rather, times 2 over, and your book foils it out. I'm going to foil it out just so we can real quick. Anything convenient happen? The 2's. So it looks like I'm simply left, after they divide out, with this expression, which is exactly what the book said. I would recommend, and I would rather stop at this point, but as long as you have a way to do it, I'm going to leave it up to you guys, subjective. What do you consider nicest? Cool. All right. Doable? Sweet. Where did you go wrong? What made it so hard? The log. Excuse me. Yeah, it certainly can be a challenge here, but if you recognized and you saw it right away when we were talking about it, at least, that it's subtracted, hard problem becomes easy. Did anybody do it without expanding the log? Good. With u prime with quotient rule? Okay, cool. So we'll pause it back. About 37 real quick. How are the AP problems? Okay, I guess we'll find out, huh? All right, 37. Ooh, S of t. We must be doing what? Position. This is a physics problem for sure. The natural log of the arctangent of t. All right. Well, I'll take the derivative of the left. Now, here's the only weird part. I'm going to put a little note off on the side here. What's u for this natural log? The arctangent of t. Okay, which means we're going to need u prime, right? Now, this one, if you don't remember it, it's always going to be a challenge. U prime over 1 plus u squared, every time. What's u prime of this guy? And I know it's weird because we have a u and then there's another u that hides inside. It happens. What's the derivative of this argument? 1 over, what happens? 1 plus t squared. Okay, so this is u prime, and now we need to take u prime over u, right? So if we're trying to do this, the natural log's derivative is u prime over u. So let's see, it's 1 over 1 plus t squared, that was u prime, over the arctangent of t. I'm okay with this. If we wanted to clean it up, could we? How? What if I didn't want a complex fraction, which is just 3 pieces or more? So I heard divide and multiply, and I think you're both right, even though we just said the exact same opposite things. I'm going to multiply by the reciprocal of arctan. Now, there's 2 ways you can do this. Either the reciprocal of arctangent is defined as arccotangent, or we can just keep arctangent down here, like this, and we're done. Cool. Don't panic when you see ugly derivative stuff. The rules are wonky, for sure, especially if we have to use, like, quotient stuff, like no quotient rule. But if we have to do a fraction with a fraction, it can get ugly. Trust your algebra. I trust your algebra. Like, you've obviously done a bunch of it to get here. Cool. All right. Then we got a few AP problems. On AP number 1, what did you guys get? Bravo. Cool. Now, they give us f of x and they say f of ln x. That is just a chain rule, right? F prime of ln x times derivative of that argument. We should get bravo. Cool. All right, we did 1, 2, 4. Number 2, what did you guys get for the derivative of x squared e to the natural log of x cubed? Grosser than it looks, or easier than it looks. It looks really awful. Charlie. As I'm looking at this expression, oh, and you can't see it. Sorry, I said I wasn't going to do this. There's something awesome that happens here. What's the derivative of e? Not, sorry. I said derivative. What's the inverse of e to the x? Natural log. What happens if you have e to a natural log? This is really just a super ugly way to write x to the 5th power, because your e and your ln undo each other, and you get x squared times x cubed, which is x to the 5th, and 5x to the 4th. We're done. Cool. The fact that e and ln are inverses save us there. Okay, on number 3, natural log. Natural log is x squared plus 4, or the natural log of h prime. Looks like 2x over x squared plus 4, right? Which means bravo. All right. Now, this is a wonky way to ask it, but I want to make sure we're all on the same page. If I said, or they said, find the rate of change of a function y with respect to x, what do they ask me to do? The rate of change. Give me another word for rate of change. Slope. And what finds a slope? Derivative. This is just saying find the derivative of this function when x is 1. So if we take the derivative, should we do this one together? So natural log of xy equals x when x equals 1. All right. And today's going to be pretty chill. I wish that I'd thought a little bit more about the traveling people, but we'll persevere. I already forgot the function. Already forgot it. Still forgot it. ln xy equals x. Okay. All right. We have some interesting decisions. We could differentiate right here, right now. Is that what you guys would do? And rather than saying, hey, here's what I would suggest, because there's not a single right way, I want 30 seconds of discussion with your neighbors. I want a first idea. There's 2 routes in my head that I might consider taking with this problem. Don't care which one you guys give me, but talk it out. Let's see what you and your neighbor come up with. 30 seconds, and then I'm just going to let somebody volunteer, or the calculator will volunteer somebody to see which way we're going to go through this problem. Talk it out. What are we doing first if I call on you? What I see, just so you guys are aware, is you could just jump right in and take the derivative of a natural log with an argument that's a product and implicitly defined. That works. That's fine. You could also do what, Riley? You could expand it. My first thought is neither of those in reality. What do you think they're doing? Huh. All right. My first thought, we're going to expand this. I'm fine with that. This is my first thought. I think about exponentiating it base e to undo everything. Now, they're all equally valid. Abigail seems to like that idea based on the facial expression. I'm okay with it. Let's just kick forward. If we expand it, because that's a natural first choice. Cool. How does this expand? So, JJ, love it and hate it simultaneously. When you say log, just so you know, because if you haven't done a bunch of log stuff, if you say the log of x, it is implied in that language that you're talking log base 10 of x. If you're going to use this, make sure you call it natural log or ln. I'm okay with either. Anybody know why ln? So base e, but why is it, so if it's a natural log, why is it not NL? That's right, because the French speak differently than us. Log de natural, that's it. Like, there it is. Cool. All right, equals x, and we're good. Then what would you do? What are we trying to find for? Presumably for y prime, but I don't know that yet necessarily. I just need to know x when x is 1 at the end. Okay, do you want me to move anything, or do we just kind of differentiate here and now? Not rhetorical. Differentiate, sure. Way to pull the trigger there. All right, here we go. What's the derivative with respect to x of the natural log of x? 1 over x, you got it. Plus y prime over y equals 1. Now, we're going to get ourselves into a goofy situation here, but we'll deal with it. I'm trying to solve for what now? Sure, I suppose that seems natural. We're trying to find the slope, so yeah. I'm going to do a big step here, and you guys are going to tell me if you don't understand what just happened. Looks like it's going to be x minus 1 over x. What did I do, and did I make a mistake? Nope, I feel pretty good about it. So I didn't really divide. I just subtracted 1 over x to the other side. But in the process of doing so, if it's not like immediately clear, I'm okay with that. Do you guys agree it's really going to come out to be this? And if I want a common denominator, instead of 1, what would I write here? X over x, and now there's my x minus 1 over x. Cool. Y prime equals, and I'm just going to say y times, and it's x minus 1 over x. And all I've done is I've cleaned it up with a single fraction and multiplied by y. Okay, now this is all fine and dandy, except I don't know that we're quite done. We need to find y prime of 1, right? But check it out. How many variables are in my derivative? 2. So this is going to be ugly notation, maybe not terribly ugly. But if I want to know what the value is when x equals 1, I also need to know the value to plug in for y, right? So what we're really trying to evaluate here is y prime of 1 comma, and I don't know what it is yet. So there's a big question mark right here for now. Huh? Cool. Well, how on earth do I figure out the y value that's in there? Is this point that we're trying to find the slope at on the original graph or on the graph of f? Sorry, is it on the graph of f or f prime? So if it's on the graph of f, so on f, if x is 1, what is y? That's the real question that we're dealing with, right? Because we need to know the y value there because I have a derivative with x and y in it. All right, well, let's go back to our original function and see if we can't figure that out. If we tried to do that, the natural log of 1 times y, and I'm going to make this really stand out. I wouldn't truly write the 1 if I were you, but 1 times y equals, what was x again? Or it's when x is equal to what value? All right, so we have the natural log of y equals 1. Okay, help me out with the log stuff because we're probably rusty. Natural log is log base what? E. So we have log base e of y equals 1. How on earth do logs work? If and only if. If you have to check our definition from the other day, I think we redefined it the other day. Something to something equals something. It's not e to the y. And the way that I taught this in algebra, when we write this, or pre-calc rather, when we write this, people always get confused about e to the y, right? Like that's where people get goofed up. I want you to tell me if what I'm going to write something and you tell me why you hate it. 2 to the power of x. Why do we hate this? I hope you hate it. I hate it. Anybody write 2 to the x like that? What feels weird about it or is wrong about it? One more time, because all I heard was... I bet you're right. My guess is you're probably right. Nope, we're gonna pull it out. What is it? What did you say? Oh my gosh, it's obnoxiously big and large and gross. Yes, that's spot on. Everybody agree that this looks awful. Like nobody does that. When we truly write log base e, I do this not super small because it takes a lot of time. If I wanted this to be the exponent, we run into this situation, it looks dumb again. We're not going to deal with that. When we look at this, what's the base of this log? E, and it's always weird, but the way it's defined is this is the power. And I know that rule for what's big, like it'd still be a bigger exponent, it would still look stupid, but that's okay because it's on the other side. It's clearly not this one. This is true if y equals e to the power of 1, which, what's e to the 1? E. Holy cow, check this out. All of this, and I'm going to switch color on mine, comes back in here. E is my point. All of a sudden, we now have y prime of 1 comma e, which equals e times 0 over 1, because it's 1 minus 1 over 0, which when we do that, where do we wind up? What's e times 0? And holy bravo was our answer. It is one of them. Now, it's tricky on this one. Even if you got the derivative and you did this part, like awesome if you got to here. And how many of you got to here, just out of curiosity? Okay. Where did you guys fall off? Fern, did you get to here?
No, I got to y equals e, but then I just didn't do this.
Oh, you even got further?
No, I did just that part. But
okay. Okay. Always try. Like realistically on the multiple choice of AP stuff, 3 minutes is roughly what you're trying for each problem. And if you go 3 minutes or more and you have to guess, that's fine. If you got the E part, I'd say that's the harder part of this problem. Cool. All right. So I should probably take it. Or we could spin the wheel since I haven't heard anybody tear it out yet. Okay. Riley's spinning the wheel for us today. Big money, big money. Give Holloway all the cash in your pocket. Weird. It was actually collect. So I take late work if you don't have it. And if you haven't done it, there is value in doing it. So it's, oh, why are you so adamant about not collecting it then? Okay. All right.
I forgot to minus.
Okay. Thank you. Thank you. Thank you. Thank you. Thank you. Staple? Okay. I will staple them. All right. So here's where we are at. It's the end of a chapter. Okay. I need your guys' input. For this, I don't have the test for today, just so you guys are aware. Unless, like, I could probably print it right now if you guys wanted to knock it out. What is the hardest thing about this chapter? You guys elected not to do the quiz midway through. Do you remember all the stuff that we've done? Implicit derivatives, inverse trig derivatives, logs. And that's pretty much it. Along with all the basic rules with U and chain rule stuff involved. So we were chain ruling this chapter. That was a main goal. Okay, for today, I think what I would like to do is let you guys study for the next 20 minutes. Okay, tomorrow we're going to do a practice test. Like, it's going to happen. I think I want to make it a team test because I think there's value in that. Here's the deal. Team tests, moving forward, what we'll do is, I think we might have already talked about this, but if not, you can use note card on your team test. Cool. You hopefully will find value in making a note card. If you actually make one, I think they're helpful. I want you, and you should make a note card this evening with stuff. Now, we'll go through the team test tomorrow. We'll review at least Wednesday, depending on how it goes. If it's super rough, we might need Wednesday, Thursday for that review stuff. We'll just play it by ear. But no, by the end of the week, we will take the Chapter 3 test. Sweet. 20 minutes of independent time without me to study and start making note cards seem okay. All right, more so, let's go ahead and cheat sheet, since it's just for the practice stuff. I'm okay with a sheet of paper. I'm good with it. Like, you're not going to use it on the real test. You can use it on the practice test. A whole sheet of paper. If you'd like different colored paper, I can give you something so it'll stand out a little bit. But a whole sheet, yellow paper, okay? We're Raiders. Yellow gold color. Cool. All right. You guys can put whatever you want on a sheet of yellow paper here. Now, if you are looking for a place to study, and we skipped a couple sections, that's okay because it doesn't show up in ours. But I do want to show you, I don't know if I should really show you this. I'm going to change the tests starting with this chapter. I'm going to quit using the ones that they give me. I'm going to start making them much more true AP tests. Okay, you'll see, like, we'll start working for it. Here's one thing that I want you to know. This is not my entire problem bank, but here, if you turn a few more pages, this is page 274. So we skipped sections 5 and 6 because they are BC only topics. But as we're looking at it, if I were getting my problems anywhere other than old AP tests, which a lot of them will just be old AP problems, check it out. Here are all the review exercises for the chapter for which I could pull from. Now, every single one of these problems is fair game, with the exception, so that's not quite true. Everything from 1.3.1 to 3.4 is fair game. If you wanted to really show me, you could just do all these problems. I don't think you should realistically do like 60 problems tonight. I think that sounds like a terrible way to spend a Monday. But there are a whole collection of problems here, or objectives here, that you guys can see. And if we wanted to know what did we do, here's a great place to look. So in that first section, on the top of page 275, you will find this, I think. Does you guys have this? On 275? Can you differentiate with composites, f of g? Can you differentiate a to the x? Can you use the power rule? Can you use the chain rule? Can you do it implicitly? Can you find second or third or fourth derivatives implicitly? Can you differentiate with x to the m over n? Here is the summary of what we've done. We did not talk about differentials and stuff. This is all we covered. Cool. I will get you guys this lovely, you guys can come, everybody wants one, I assume, would be my guess. Would you like a, cool. What? You get one side, and apparently I was going to make flashcards at one point, and I misprinted, so you guys are in luck. I would only use the side that doesn't have writing on it. Mm-hmm. Yep. And I will be making a couple of you guys do some proofreading stuff for me. You're welcome. Man, my stack of recommendations is so huge. I have 4 polished and ready to be proofread. The rest of them will be done tomorrow. I will print those out for you guys. Okay, what are we doing tomorrow in class?